All right, today we are doing section 2.3 on complementary and supplementary angles. Our objective is to find the measures of complementary and supplementary angles. Remember, to name an angle, we only use 3 letters. On number 1, we need an obtuse angle. So what angle there appears to be obtuse? Angle DBE appears to be obtuse. Angle DBE, so that's this angle here. It appears to be obtuse. I would recommend having the diagram. You don't need to write out all the directions, but I would have the diagram. All right, we need an angle that is right. Brandon? ABD. Angle ABD is right. How did you know that?
It has a box.
Very good. Angle ABD. Your other option on this one technically would be DBC. That would also be a right angle. What about an angle that appears to be acute? We've got several options. Angel. DBF, yes. Angle DBF appears to be acute. Anybody come up with a different one? Nikitra? ABE appears to be acute. Jaden?
FBC.
And angle FBC. All of those appear to be acute, so any of those would be correct. What about number 4, a straight angle? We only have one option here. EBF's not quite straight. That line gets a little crooked there. If this were to go, angle ABC is the only one that is really straight. Our vocab for today, complementary angles, 2 angles whose measure have a sum of 90 degrees. Sum means what operation? Addition. So 2 angles whose measures add up to 90. Okay, so a picture for that could look something like this, where it's a right angle and you have it split into 2 different angles. That's a possible diagram. But they don't have to be touching each other like that. You could have one here that's like 21 degrees. You could have another angle over here that would then add up with that. So this one would have to be 69 degrees. These 2 are also an option for a diagram of complementary angles. They don't have to be touching each other. It's just 2 angles who have a sum of 90 degrees. So those would be 2 separate diagram options. We can have the same kind of situation with supplementary. Same kind of thing can happen for supplementary angles. This time they add up to 180 degrees. So I'm going to make some space up here for a diagram for supplementary. So again, for supplementary degrees, it could just be a straight angle that is split somewhere. Those would have to be supplementary. Or you could have 2 totally separate angles, like 2 right angles that are not connected to each other. So again, we have 2 options for supplementary diagrams. So that is the diagram for supplementary. All right, now for adjacent angles. 2 angles that share a common vertex and one side but have no common interior points. Really, we've already shown a couple examples of this, but we will show another one. So for them to be adjacent, that's when they're connected to each other Okay, so they've got this common vertex down here, and they have one side that they share. Common vertex, share a side. But they don't overlap each other. So that's what that last part means about the common interior points. No point that you pick on the interior of this top angle is also going to be on the interior of the bottom one. Okay, so let's get some theorems down, some true statements that follow from other true statements. First, we have the congruent complements theorem. If two angles are complementary to the same angle, then they are congruent. Okay, similarly, we have the congruent supplements theorem. If two angles are supplementary to the same angle, then they are congruent. In more of an equation form of the same thing, if the measures of angles 1 and 2 add up to 90, and the measures of 2 and 3 add up to 90, then 1 and 3 must be congruent to each other. Same thing goes for supplementary. If 4 and 5 add up to 180, and 5 and 6 add up to 180, then 4 and 6 must be congruent. And we could prove this using some basic algebra, but we won't necessarily write a proof for it just yet. So we have to decide if they are complementary, meaning they add up to 90, supplementary, they add up to 180, or neither. If they don't add up to either 90 or 180, we don't really care about them right now. So on part A, we have 40 degrees and 30 degrees. What does that add up to? 70. So our answer for this one would be neither. If it's not 90 or 180, then it is neither. All right, on B, we've got 135 and 45. What does that add up to? 180. So our answer would be supplementary. No. Write out the whole word. All right, part C, 62 degrees and 28 degrees. That would add up to 90, meaning they are complementary. No, unless the directions say to. All right, so we are asked if these are adjacent or non-adjacent. So in English, we think of adjacent as just being next to, but in geometry, it's a little more specific than that. They have to share a side. Okay, so for A, would these be considered adjacent in geometry? Yes, they've got a common endpoint, they share a side, they don't overlap each other. So yes, these would be considered adjacent. What about part B, angles 3 and 4? So on part B, are these considered adjacent in geometry? Angles 3 and 4. No, why not? Okay, good. They're separated from each other. Even though they share a common endpoint, they don't have a common side. Okay, we can draw both of them without ever drawing the same side twice. So in geometry, these would be considered non-adjacent. All right, what about C, angles 5 and 6? Are those adjacent? No, why not? So I agree that they are non-adjacent, but we have to be able to tell why. They don't have a common endpoint, for starters. Okay, this one at least had a common endpoint. They don't have a common endpoint or a common side. So even though they're sitting next to each other, in geometry they are considered non-adjacent also. All right, for number 3, F is a complement of angle G, and the measure of angle F is equal to 23 degrees. We are asked to find the measure of angle G. Okay, the work I'm going to show is not something that I'm going to expect every single time, but I'm going to go through it this time so that you can see where these answers are coming from. If angles F and G are complementary, their measures add up to what? 90 degrees. So I know from the beginning the measure of angle F plus the measure of angle G is going to be equal to 90 degrees. From that first sentence, I can set that up. Then they tell me what the measure of angle F is, so I can substitute that in or plug that in. Now really, this goes back to algebra. How am I going to figure out what the measure of angle G is? Jaden? Okay, subtract 23 from both sides. If I subtract 23 from both sides, I keep my equation balanced, but I would have the measure of angle G by itself. So I subtract 23 on both sides. So the measure of angle G equals 67 degrees. All right, on number 4, we are told that angles S and T are supplements, meaning that they add up to 180. So again, the measure of angle S plus the measure of angle T equals 180 degrees. We are told that the measure of angle S is 95 degrees, so I can plug that in or substitute it in. 95 plus the measure of angle T is equal to 180 degrees. Just like the last one, what am I going to do to get angle T by itself? Subtract 95 from both sides. This is just like an equation from algebra, except for instead of having just a variable here, we're describing what it is that we're measuring. The measure of angle T, that's what we're looking for. So we get the measure of angle T equals 85 degrees. If you're telling me the measure of an angle, make sure you're including your degree symbol. All right. Angle 1 and angle 3 are complementary, and angle 3 and angle 5 are complementary. Name a pair of congruent angles and explain. So if you're not sure about it, just by reading it, pick some hypothetical measures. We picked 56 for angle 1, making angle 3 34 degrees. Angle 3 is still 34 degrees over here. If it's complementary to angle 5 is also 56 degrees. So from that, we can determine that angle 1 is congruent to angle 5. If we need an explanation of why, it's not really going to work to use a hypothetical case. The real reason why is because they are both complementary to angle 3. Angle 1 and angle 5 are both complementary to angle 3. So that goes back to the congruent complements theorem that we filled in on the front of the notes. All right, we are asked to find the value of x. We have done problems similar to this before.
So is it 4 or not?
We've done problems similar to these before, but nothing exactly like this. When we've done problems like this before, we were doing angle addition or we had bisectors. This is more like angle addition. If I add these two angles up, what does it have to equal? That makes a straight line here. 180. Okay, these two angles are supplementary to each other. Okay, they make a straight angle when they're put together. So if I add them together, 4x minus 10 plus x plus 5, so I added those two pieces together. You don't need the parentheses there, but it helps show it a little clearer. It should equal what number? 180. So we are setting up an equation to solve. If we add those two angles together, it should equal 180. We have to be able to recognize that from the diagram. So now we start doing our algebra. 4x plus x. 5x. Negative 10 plus 5 is a negative 5. So we simplified that side. Now we have to solve it. What do I do? Add 5 to both sides. 5x equals 185. Then what? Divide by 5. What do we get? Nobody got it yet? I think it's 37. 37. All right. And that's all we were asked for was the value of x. So we don't have to worry about plugging it back in and finding anything else. We were just wanting the value of x. Based on how we did 6a, what do you think I'm doing on 6b? The same exact thing? What would they equal? 90. Technically, we should have a little box here to really make that obvious. But that is the intention on this one. We are going to add them together. X minus 15 plus 2x plus 6. They are complementary, so they equal 90 when we add them together. All right, let's combine like terms. X plus 2x. Negative 15 plus 6 equals 90. To solve, add 9 to both sides. 3x equals 99. And then divide by 3. X equals 33. Again, all we were asked to do was find the value of x, so that's the end of that problem.